I just want to make a few announcements before we begin quickly. Thanks to everybody for joining. I'm Shannon Kavanda, and I'm part of the project team support, excuse me. Just a few things to note before we begin. To preserve bandwidth, attendees are muted for now and your video has been disabled. Although you're muted, you can submit questions or comments throughout the upcoming presentation, and we will address them after the presentation. You can also use the Q&A button in the lower right corner of your screen to type in questions or comments. If you'd like to make a comment or ask a question out loud after the presentation, please use the hand raise function. We will unmute you when it's your turn to ask your question. For those calling into our public meeting, you can hit *6 on your phone after the presentation to be unmuted and ask your question verbally. Lastly, please be advised that this meeting will be recorded. I will now turn it over to Chair Lidstrom to convene the meeting. Thank you.
Great. Thank you, Shannon, and welcome everybody. Thanks so much for joining us this afternoon and to learn a little bit more and hear a little bit more about this really critical and important project that we are undertaking at the Met Council. I am Peter Lindstrom, and I'm the chair of the Environment Committee for the Met Council and a member of the council. I represent District 10. Before we get too far down the line here, is there any city officials or Met Council members or city staff that are joining us today? If you are, would love to recognize you. Just hit that raise hand function. So great that we have a good number of folks attending today. I don't see anybody, so if we could jump to the next slide. Again, I'm Peter Lindstrom from the Met Council, and we have with us Janine Clancy. Janine, could you unmute and turn on your camera and introduce yourself?
Good afternoon, everyone. Thanks for being here today. My name is Janine Clancy. I'm the Assistant General Manager for Wastewater Planning and Capital Project Delivery for Metropolitan Council Environmental Services. Thank you.
Thank you, Janine. And Renee Heflin.
Renee Heflin here. I am a manager of the Plant Engineering Group for the Metropolitan Council.
Wonderful, thank you. And Stephen Norton.
Good afternoon, everyone. My name is Stephen Norton. I'm a principal engineer with Metropolitan Council Environmental Services, and I'm the project manager for the Metro Plant Solids Management Improvements Project. Thanks.
Thank you. The purpose, if we could advance to the next slide, the purpose of our meeting today is to share information on the status of this important project, the Metro Plant Solids Management Improvements Project, and provide an opportunity for future public engagement. Next slide. Our topics today we're hoping to cover include an overview, including the background information, project information, and an updated project schedule, how it works, including how solids are processed at the Metro plant. We're hoping to cover information related to air permitting and environmental review, as well as a summary, including where to find more information and future public engagement opportunities. And with that, I'll turn it over to Janine Clancy to talk more about the overview of this great project.
And thank you again, Chair Lindstrom. And thanks everyone again for attending today so that you can learn about the work that my team and I are doing regarding the Metro Plant Solids Management Improvement Project. Next. Metropolitan Council Environmental Services is a regional wastewater utility. We provide wastewater collection and treatment services to 110 cities in the 7-county Twin Cities metropolitan area. Our infrastructure includes 640 miles of pipes, which are called interceptors, and these pipes convey wastewater to 9 wastewater treatment plants. On average, we treat 250 million gallons of wastewater every day that is generated from 2.6 million people who live here. The wastewater system is valued at over $7 billion. To keep the system operating in good condition, MCES spends about $150 million per year in capital projects. To provide the level of service that the region has come to expect, our organization employs about 650 people, including licensed operators, electricians, machinists, service workers, and other trades, as well as scientists, engineers, and planners. MCES is proud of the work that we do. The services that we provide protect public health, protect the environment, and supports economic growth of the region. On this slide, please note the please note the service areas for our 9 wastewater treatment plants. The area in green is the service area for the Metro plant. The service area for the Metro plant is 2 million people. The arrows illustrate that the plant is receiving solids from 4 other small treatment plants: East Bethel, St. Croix Valley, Eagles Point, and Hastings. Solids are transported using the tanker trucks that are shown on the lower left side of the slide. About 20 tanker trucks of solids are transported each day to the Metro plant from our other wastewater treatment facilities. Next. The proposed project will be constructed at the Metropolitan Wastewater Treatment Plant located at 2400 Childs Road. The Metro plant treats 180 million gallons of wastewater every day. That's about 75% of the region's wastewater. The Metro plant also treats about 850 wet tons of wastewater solids on a daily basis. It might be hard to imagine how much 850 wet tons is, so my staff did some calculations to help us visualize the volume. 850 wet tons is equivalent to 20 airplanes, 140 elephants, or 420 cars. The incineration process reduces the 850 wet tons of wastewater solids down to 40 tons of inert ash. The energy recovery system reduces purchases of natural gas and electricity by $2 million per year. Next. The Metro plant needs additional solids processing capacity for 2 reasons: asset preservation and growth. In 2025, the existing incinerators will be 20 years old and in need of a very intensive renewal project. We estimate that the renewal work required will take about 1 year for each of the 3 incinerators. We currently do not have the capacity to take an incinerator out of service for a year. By building a 4th incinerator, we will have the capacity needed to renew existing incineration facilities. Additional capacity is also needed to serve regional population growth. The population of the Metro plant service area is expected to increase by 500,000 people by 2050. While wastewater flows are historically holding steady due to water conservation efforts and reductions of inflow and infiltration, the solids generated will increase with population growth, and capacity is needed to treat an additional 215 wet tons per day by 2050. The region is growing, and MCES needs to support regional economic growth by maintaining state-of-the-art treatment facilities at affordable rates. Next. Currently, MCES is undertaking a minor capital project to address incineration equipment concerns. Beginning in 2024, MCES proposes to begin construction of a fourth parallel incineration train similar to our existing systems with comparable energy recovery and air pollution control systems. An extensive renewal will then be completed on the existing incinerators 1, 2, and 3 from about 2027 to 2029. In summary, MCES will be spending roughly $200 million over the next 8 years on Metro Plant solids projects. Next slide. Our proposed project includes expanding the existing solids management building by 21,000 square feet, as shown on this slide. The incineration equipment, which is shown in green, will be housed in the expansion. The stack for the fourth incinerator will be located at the same location and height as the existing 3 stacks, which are noted on the right side of the slide. The project will include additional dewatering facilities, a fourth incinerator, energy recovery including new steam turbine generator, and air pollution control. The project also improves receiving facilities so that MCES can accept dewater solids from the other MCES treatment plants on an emergency backup basis. Next. Significant outreach activities were performed in 2018 to local government entities, our customer communities, as well as our industrial customers, regulatory agencies, businesses around the Metro Plant, neighborhood districts in St. Paul, community organizations, and environmental advocacy organizations. In addition, over 4,000 mailings were sent out to residents surrounding the plant to let them know about the project. MCES held an open house event and formal public hearing to receive public comments on the project. During the public outreach held in 2018, there were no concerns expressed with regard to odor, noise, or traffic. As part of the facility plan, an alternatives analysis was completed, which included cost and non-cost factors. The fourth incinerator was found to be the most cost-effective and sustainable alternative to meet the region's wastewater needs. Following the public outreach, MCES responding to the public comments, the Metropolitan Council formally adopted and approved the facility plan for the project in October of 2018. And later on in the presentation, I'll provide the address for our website where the facility plan can be viewed. Next. Planning was completed at the end of 2018 when the council approved the facility plan. And we have now retained the services of an owner agent, and the project will be delivered using the design build method. Currently, the project is in preliminary design, including permitting and environmental review. The Metro Plant's air permit will be amended, and a voluntary environmental assessment worksheet, also known as an EAW, will be completed. The air permit amendment and EAW will be managed by the Minnesota Pollution Control Agency, referred to as MPCA, and each will include their own public notice and potentially a public meeting. The fourth incinerator construction will be completed from 2024 through 2026. Upon successful commissioning of the system, renewal of the existing incineration facilities will begin. Now I'd like to turn it over to Stephen Norton to talk about how solids is processed at the Metro Plant.
Thanks, Janine. For my part of the presentation, I'll discuss how solids are processed at the Metro Plant. Next slide. Wastewater comes to the Metro plant from households, industries, businesses, and institutions such as schools and includes solids and other pollutants. A wastewater treatment plant separates solids from the liquid portion and must treat both. Wastewater solids are collected in two locations, primary settling and final settling tanks. Primary settling tanks give the solids in the wastewater time to settle out and fall to the bottom of the tank where they are collected. The final settling tanks remove solids which the plant has actually grown in order to treat the liquids portion of the wastewater. The solids collected at the bottom of the primary and final settling tanks are roughly 1% solid and 99% liquids. In order to prepare the solids for incineration, the solids need to be thickened and then dewatered to roughly 30% solids and 70% liquid. At this point, we call the dewater solids cake and is a similar texture to a moist soil and sort of looks like Play-Doh when it's pumped through the pipes. Next slide. The solids that are collected have a lot of value. After the wastewater solids are dewatered, they have a heating value that's similar to a wood or low-grade coal. You probably don't want to throw our solids on your next campfire, but they do make a great renewable fuel source that is ideal for incineration. Next slide. At the Metro plant, we use fluidized bed incineration technology. A fluidized bed incinerator contains a bed of sand and air is distributed under the bed, which causes the sand to swirl and act like a fluid, much like a boiling pot of water. Once reaching a temperature of roughly 1400 degrees Fahrenheit, the solids have enough energy that the incinerators normally operate without the need for supplemental fuel. As long as the solids are fed, the combustion continues. The combustion of the solids release flue gas containing water vapor, carbon dioxide, and fine ash particles through the top of the incinerator, which all go through further treatment. Like Janine mentioned, MCS has to process 850 tons of wastewater solids every day. And one of the major benefits of incineration is that it makes 810 tons of that material disappear. After incineration, we're left with only 40 tons per day of dry inert ash, which is roughly 2 trucks per day. If we did not have incineration and we had to add drying agents and other materials to control pH, we would end up running roughly 75 trucks per day from the Metro plant. Next slide. Following incineration, the hot flue gas goes through an energy recovery system, which captures the thermal energy, ultimately reducing purchased natural gas and electricity. The first location where energy is recovered is at the primary heat exchanger. The heat exchanger preheats the air that's going into the bottom of the incinerator, minimizing the need for supplemental fuel and natural gas to maintain combustion. The next location where energy is recovered is at the waste heat boiler. The waste heat boiler consists of hundreds of metal tubes, which water is pumped through to produce steam. During the winter months, the steam provides heating to buildings around the plant. During the summer months, the steam is sent to a steam turbine generator to generate electricity. Electricity generation from wastewater solids at the Metro plant accounts for roughly 10% of the plant's power demand. The combined savings of purchased natural gas and electricity is roughly $2 million per year. Next slide. Following energy recovery, the Metro plant uses state-of-the-art air pollution control equipment to meet very stringent air emission regulations. First, the flue gas goes through a carbon tower where carbon is injected to remove mercury. Next, a baghouse uses over 800 cloth filter bags to filter out particulates and heavy metals. Next, a wet scrubber uses water cooling sprays to remove particulates and acid gases. Next, a wet electrostatic precipitator collects fine particles onto electrically charged tubes. Finally, the gas travels through a heat exchanger, which removes any remaining moisture and then out the stack. All in all, the air pollution control system removes over 99% of all the particulates and heavy metals leaving the incinerator. The emissions leaving the stack are clean, colorless, odorless, and have no visible plume. And with that, I'll turn it over to Renee to talk about the air permitting and environmental review.
Thank you, Stephen. My role is to present some of the preliminary design work, including evaluations we completed to obtain an air permit for the fourth incinerator and the evaluations we completed for environmental review. Next. MCES recognizes that neighborhoods surrounding the metro plant include environmental justice areas identified by the Minnesota Pollution Control Agency, or the MPCA. This map is from the MPCA's website. 40% or more of the residents in the blue areas reported income less than 185% of the federal poverty level. 50% or more of the residents in the green areas are people of color. Using the MPCA's framework to evaluate environmental impacts of the fourth incinerator project, we found that this project will have no significant detrimental impacts to surrounding communities. These evaluations which are included in the application to modify the plant's air permit for a new incinerator, and the Project Environmental Assessment Worksheet, or EAW, will be independently reviewed by the PCA. The public will be provided opportunity to review and comment on the air permit and the EAW. The public review process, as Janine mentioned, will be managed by the MPCA, and we anticipate that the MPCA will issue public notice towards the end of this year or early next year. Now I want to share with you some of the results of our environmental evaluations. Next. As part of the air permit amendment, before the fourth incinerator is constructed, MCS must demonstrate through computer modeling that after construction of the project, the metro plant will continue to meet national ambient air quality standards at the plant property boundary. National ambient air quality standards have been established by the Environmental Protection Agency for 6 criteria pollutants for the protection of human health and the environment. Our preliminary modeling results indicate that the metro plant will continue to meet all national ambient air quality standards and that the project will have no significant impact on the air quality for surrounding communities. These modeling results will be updated in the near future because the PCA is updating the modeling requirements. If you look towards the bottom of the criteria pollutants, PM2.5 is small airborne particulate matter or material with a diameter less than or equal to 2.5 microns. PM10 is particulate matter with a diameter less than or equal to 10 microns. On the next slide, I'm going to talk a little bit more about the particulate matter pollutants. Next. The graph on the left side of this slide shows a gradation of micron particle sizes from the smallest, a smoke particle at 0.5 microns, to the largest, a coffee ground at 100 microns. A PM10 particle is about the size of a pollen particle. Breathing in large concentrations of PM10 can damage your lungs, and that's why there's an air quality standard in place for PM10. In 1994, the blue area shown on the map surrounding the metro plant and other industries was above the national ambient air quality standards for PM10. The area includes Childs Road and Red Rock Road. When an area exceeds a national ambient air quality standard for any given pollutant, the PCA identifies the area as non-attainment for that pollutant. In response to non-attainment for PM10, the MPCA developed a State Implementation Plan, or SIP, which is a collection of regulations and requirements for the area to bring it back below the National Ambient Air Quality Standard for PM10. Emissions reductions successfully brought this area back into attainment for PM10 in 2002. MCS has played a role in improving air quality in the area by replacing its multiple hearth incinerators with fluid bed incinerators in 2005. However, once an area is identified as non-attainment for a particular pollutant, when the conditions improve and the air quality standard is met, the area is redesignated as a maintenance area for that pollutant. When there's a project in a maintenance area, the EPA may choose to review its state implementation plan, depending on the project, and make additional monitoring and/or modeling requirements to ensure the area remains in compliance. The fourth incinerator project will actually reduce the Metro plant's potential to emit PM10 by almost 2.5 tons per year from what was previously permitted. That's because we didn't construct previously planned facilities for land application of sludge, and we were able to accept a really low PM10 limit due to the excellent performance of air pollution control equipment in removing particulates from incinerator emissions. Next. The existing Metro plant incinerators have an exceptional track record of environmental compliance, and MCS is proud of their performance. The Metro plant incinerators have performed so well that the emissions data from the Metro plant were used by the EPA in establishing new, more stringent standards specifically for incinerators in 2010. In 2010, the EPA set new air emission standards for existing sewage sludge incinerators constructed before 2010, and even lower standards for incinerators constructed after 2010. These standards are based on treatment technology and are separate from the National Ambient Air Quality Standards presented previously. The existing incinerators at the Metro plant were constructed in 2005, so the standards for existing incinerators apply. This graph shows our existing emissions compared to the new standards, new incinerator standards. The pollutants of concern are listed along the x-axis: total suspended particulates, carbon monoxide, sulfur dioxide, etc. Each standard or limit is represented as 100%, the dark blue dashes at the top of the graph. For each pollutant of concern, our emissions, the dark blue bars, are a fraction of the new standard. These results give us confidence that the new fourth incinerator will be capable of meeting the lower technology-based standards established for new sewage sludge incinerators. Next. This map is an example evaluation we completed for the Environmental Assessment Worksheet, or EAW. This is the environmental review. A large part of the EAW is Air Emissions Risk Analyses, or AERA. An AERA quantifies potential human health risk due to emissions from a proposed project. There are 8 different types of situations or scenarios that must be evaluated. This example is the resident cancer scenario. The resident cancer scenario assumes a lifetime of inhalation, 30 years of ingesting home-grown produce, and indirectly ingesting soil. The analyses are at the facility boundary and beyond. We completed our computer modeling for total Metro plant emissions, not just the fourth incinerator project. The green highlight indicates areas that pass and are 10% or more of the risk threshold. 10% is the outer boundary, and risk increases towards the plant fence line. White lines represent risk in 10% increments from the outer green boundary, outside green boundary towards the plant at the center. Yellow highlight would indicate exceedance of the risk threshold, and additional mitigation measures would be required. You can see here that for the resident cancer scenario, the Metro plant meets the risk threshold with the addition of the 4th incinerator. Note also that there are no resident farmers located within the green area. Computer modeling for the other 7 scenarios that are given in the EAW as part of the EAW show that the Metro plant meets the risk threshold for all 8 scenarios required by the EAW. Next. Next, I want to talk about greenhouse gas emissions from incineration of wastewater solids and also wastewater treatment plants. Greenhouse gas emissions from the 4th incinerator are partially offset by the energy recovery equipment that Stephen presented earlier. However, the real point is that wastewater treatment as a whole contributes very little greenhouse gas emissions in the overall scheme of things. This graph, developed by the MPCA, depicts greenhouse gas emissions by category. The various categories, commercial, residential, industrial, etc., are different colors in the columns. The left column is the estimated 2010 total greenhouse gas emissions for the state of Minnesota. And the right column is similar, is the estimated 2010 total greenhouse gas emissions for the Twin Cities metro area. The yellow segment, the sliver in the middle of these both bars, represents landfills and wastewater treatment plants. And you can see this segment is very small, and it accounts for less than 0.25% of the total bar height. Next. Incineration technology at the Metro plant has been a key factor in reducing odors from the Metro plant. Before the fluid bed incinerators were installed in 2005, the Metro plant received about 70 odor complaints each year. After the fluid bed incinerators were constructed and with odor control improvements around the plant, the Metro plant, the number of odor complaints that the Metro plant received reduced to 0. We don't really receive any odor complaints these days. Adding a 4th incinerator will not create any additional odors and will help MCS continue to be a good neighbor to surrounding communities. Next. The impact of the project on water quality is also a question or a spot to fill in on the environmental assessment worksheet. The Metro plant is located next to the Mississippi River and Pig's Eye Lake. The Metro plant has played a key role in improving water quality in the Mississippi River since its construction in 1938. The Metro plant has 8 consecutive years of perfect discharge compliance. Although this project does not directly impact liquids treatment, the addition of solids processing capacity at the plant will help minimize the risk of not being able to collect and remove solids from the liquids treatment system. There are no proposed changes to the liquids or stormwater discharges as part of the project, and nearby water resources will not be impacted by the construction or the operation of the 4th incinerator in either the short term or the long term. Next. Adding a fourth incinerator will require a major amendment to the Metro Plant's air permit. After the PCA reviews the application for a permit amendment, they will issue a public notice, potentially a public hearing on the amended air permit, and then issue an updated air permit for the Metro Plant. Since the Metro Plant is located in the SIP maintenance area, the project will likely require SIP review by the EPA. Once the EPA reviews the SIP, they will publish the proposed revision, if any, in the Federal Register and then approve it. The environmental assessment worksheet is not required for this project, but MCS will voluntarily submit one to the PCA to provide full transparency regarding the project. The purpose of the EAW is to disclose potential environmental impacts of those projects that may have significant environmental impact and to identify mitigation measures prior to construction or permitting. After the EAW is reviewed by the MPCA, they will issue a public notice, again, potentially a public meeting. The PCA will decide if additional work is needed or if an environmental impact statement, EIS, is required. If not, if an EIS is not required, the MPCA will issue what is called a negative declaration supporting why an EIS is not required and the findings of fact. We anticipate that air permitting and environmental review, the phase we're in right now, we started in July 2020, will require up to 2.5 years to complete. And we will be ready to award the design build contract for the fourth incinerator project in 2024. Thank you for your time. And next, I will turn it back to Janine to summarize our presentation.
Well, thank you, Renee and Stephen. And just in summary, increasing solids. Oh, could we go to the next slide, please? Thank you, Shannon. Increasing solids processing capacity by adding a fourth incinerator at the Metro Plant is an important public works project for our region. We rely on wastewater treatment infrastructure to protect public health and the environment. Our current incinerators at the Metro Plant are almost 20 years old and are in need of renewal. The extent of the renewal, combined with population growth, require our organization to expand incineration capacity at the Metro Plant. The work that MCES has done in the past 20 years at the Metro Plant has contributed to improved air quality in the area surrounding the Metro Plant. Based on the performance of our existing facilities, we are confident that we can achieve the emission standards for new fluidized bed incinerators. We are also confident that we will be able to continue to achieve the energy recovery goals that we have set for our organization. In closing, the fourth incinerator is the most cost-effective and sustainable alternative to meet the region's wastewater needs. It will have the lowest community impact and will improve the reliability of the wastewater treatment system. Next. And so there are many ways for you to learn more about the project or to provide feedback. You could visit our project website, and the web address is identified on this slide. It's www.metrocouncil.org/metrosolids. You could email our project team at info@metrosolids.com. You could leave a comment on our project comment line at 651-691-9124, or you could send any written comments via mail to our Robert Street address in St. Paul, and that's noted on the slide, 390 Robert Street North, St. Paul, Minnesota, 55101. And as Renee mentioned, there are 2 future engagement opportunities, and those will be held by the Minnesota Pollution Control Agency. And those will be for the separate public notices for the air permit amendment and the environmental assessment worksheet. And again, we expect that to be towards the end of this year or early next year. And with that, I'd like to turn it back over to Chair Lindstrom. Thank you.
Thank you, Janine, and thanks everybody for those great presentations. And now we'd love to hear from you. If you have any questions or comments, now would be the time. And you can enter those questions and comments into the chat box or just use the raise hand function and we will call on you, and I'll be taking a look at that, who's raising their hands. But if my colleagues here see anybody that I missed, just pipe up. So we'll give it a second. All right. Well, thanks so much again, everybody, for participating this afternoon. Really appreciate it. And have a wonderful rest of your day.